So, but I need to substitute 1 and 2 into y and x.
Yep.
So that would be 2 is equals to ka to the power of 1, or just ka even.
Okay.
And then, oh, and then I'd have to do the same with the other one and do 128 is equals to ka to the power of minus 2.
Mm-hmm.
And then um, I'm guessing that because I know what that 2 is going to be ka. Do I need to like do like 2 over a is equals to k or something like that?
That would work, yeah.
And so I would do 128 is equals to 2 over a times a to the minus 2.
Mm-hmm.
And then, so that's just going to be 128 is equals to 2a over a to the minus 2, or is that wrong?
Do you know what a to the minus 2?
Oh, I should make that. Should I do 2? So because it's 2 over a, does that mean I need to make it into equals to 2a to the power of minus 1?
So that would work, yeah. What you might find easier is a to the minus 2 is the same as 1 over a to the plus 2. So instead of bringing the other one up, bring that one down might be easier.
Yeah. Um. Oh, and then that would just be 128 equals to 2 over a cubed,
Mm-hmm.
and then a cubed is equals to 2 over 128.
Yep.
And then I need to just cube root that, and that'll be so. Um. And so that would be. So that a is a quarter. And then if I just do, so if I sub that quarter into 2 equals to ka, so it'll be 2 is equals to a quarter k, and then it'll be that k is equals to 8.
8. That is a quarter. Oh, do I not have the... Oh, I just deleted the answer. Looks good. And when you first subbed it in, I just want to see what happens here. When you first subbed it in, 128 equals... How do I do equals again? That one. Equals 2 over... I'll use x times x to the minus 2. Shift solve, lucky 7, and yeah, you get a quarter. Okay, that's grand. Any questions there?
No.
Okay, so yes, simultaneous equations. Okay, e to the x. So e is a number that's similar to pi. It goes on forever.
Okay.
All that stuff. And if you have the graph of y is equal to 2 to the x, the derivative is like similar. If you have the graph of y is equal to 3 to the x, the graph is on the other side. So the black here is y equals 2 to the x, and the red is the graph of the derivative dy by dx. Same with this one. For this one, the red is slightly below, so the derivative is slightly below. Here, the derivative is slightly above, and there's a number in between where it's exactly the same, and that number is e. It's in between 2 and 3. It's 2.71828 dot dot dot, like pi goes on forever. It's a rational number. It is an irrational number. Basically, it's the only number where the derivative of e to the x is e to the x.
Yeah.
It's the only one that's the same. Okay. How about these?
So would the first one be just 4xe to the 4x minus 1?
Well, the derivative would be e to the 4x.
Yeah.
But you also multiply by the derivative of the function inside the function, which is 4x. And so what is the derivative of 4x?
So what does the derivative mean, sorry?
What you get when you differentiate it.
4.
Yeah. And so you just multiply that by 4.
So that would just be 4e to the 4x.
Yeah.
So.
Okay, how about B?
Okay, and then so B. So would B just be minus a half e to the minus a half x?
Mm-hmm. And C?
So would C be 6e to the 2x?
Well done. That's it. 6e to the 2x minus a half e to the minus a half x, 4e to the 4x. And if you think about it, if the derivative of e to the x is e to the x, it's not x minus 1 times by e to the x minus 1. It's just, itself.
Yeah.
And that's where everything comes from. Sketch the graphs of the following. Give the coordinates of any points.
I think that's my calculator, can't I?
You can just put it in the calculator. Yep. Let's put them in the calculator. What is anything to the power of 0?
1.
And that's why e to the x, e to the 0 is 1. E to the 2x, e to the 2 times 0 is still e to the 0, so it's still 1. So lots of these graphs will go through 1. E to the minus x also goes through 1. But then there's some other stuff, like they added some stuff, so it went up, that type of stuff. Okay. Differentiate these. Let's try it.
Okay. So, would I first of all need to make 1 over e to 6x, so there's not a fraction.
Mm-hmm.
And so would that be 8x squared minus e to the minus 6x?
Yep.
And I just differentiate that, and that would be 16x and then would that be plus 6x? No, plus 6e to the minus 6x.
Well done. And how about part B?
And then part B. So I need to expand the brackets first, don't I?
Mm-hmm.
So that would be 8e to the 4x minus 6e to the minus x, which would be equals to. Oh, and I just need to differentiate that, don't I?
Mm-hmm.
And so that would be 32e 4x plus 6e to the x
Plus 6e to the
minus x, right?
yeah. Let's see, 34e to 4x plus 6e to the minus x, and then 16x plus 6e to the minus 6x. They just wrote it as under it, but it's the same thing. Both are fine. That's fine. So the only bit of this that's new is the e part.
I was trying to come. So for e, I never have to like minus one from the power.
No.
Okay.
Okay. How about this one?
Okay. So. Sorry, I can't really see properly like that e to the 2 3x minus 1. Is that what it is?
Yep.
Okay. Okay. So, but I first of all need to expand the brackets for the e to the power.
Mm-hmm.
So would that be e to the power of 6x minus 2?
Yeah.
And then and then I need to times that by e. So would I just do 4e or something like that, or
I think this is, when do you see two power where two things being added together? When do you do that?
in like index laws?
Yes. And what is the law when they get multiplied together?
That the powers add together.
Sorry?
That the powers add together
But when? Under what circumstances do you add the
when,
indices?
when they're multiplying together.
Yes. And so what times what would result in this? It's not obvious. Well, it will be in a minute. It'll be e to the power something times by e to the power something else. What do you think?
Would it be e to the power of 6x times e to the power of minus 2?
Yes. And another way of writing this, see, e is just a number like pi. So
Yeah.
another way of writing that would be like that. And then I suppose another way still, well, I don't quite know. Let's just try to write it without the time sign, but I think that's what they're asking about. And so what is A, what is B?
So A is e to the minus 2, and then B is 6.
I believe so. Yep. A, e to the minus 2, B is 6, and then part B, they just wanted you to sketch that graph. So in this case, you had to use laws of indices in reverse. And just remember that e is just a number, like pi.
Yeah.
Okay, how do we do this?
Okay. So okay, so what's x equals to? So what I need to do I need to just put the half into either 4 of x?
That will get you the y coordinate.
So is that what I need to do, or
That'll be one part of it.
yeah?
Do you remember how to find the equation of a tangent?
No.
This is a half. So equation of a tangent is f of x1. So you find that you find f dash of x1. So this gives you the y coordinate. This gives you that. And then sub all into. So it's basically y minus y1 equals m x minus x1. So this here is y, this here is m. And so that's the same as y minus f of x1 is equal to f dash of x1 x minus x1. And they give us this x1.
So first of all,
So like you said, you sub it in to get y.
yeah.
Go on there, take your time.
So is x1 here? Is that just a half?
X1 is a half, yeah.
So I need to do f of a half. Yeah. So y is equals to f of a half, and then I need to differentiate that?
Yeah.
I'll even differentiate it. I need to do f of differentiated, f of different, like, yeah.
So just take them one at a time. So find y, find m.
So
what is y? What is the f of x?
y
Okay, so the f of a half
is half y.
You sub a half for x.
So it'll be e to the 4 to the half, e to the 4 times half, or e squared.
Yep.
So y equals to e squared, and then do I then need to do sub that all into y minus y1 equals m x minus x1?
So did you get f dash of a half?
No.
So find f dash of x.
So that would be 2e, or even 2e squared.
Of f of x is e to the 4x.
Oh, so that would be 4e to the 4x.
Yeah.
And then, is that what I need to get? Now I need to do that sub all into thing. Or do I now need to put the half into the x?
Yeah, put half into the x for this one.
So that would be 4e to the 4e squared. And then that would give would that just give 80?
Hold on.
So
So the derivative was 4e to the 4x.
yeah,
So you sub in a half for x.
yeah. So that 4e times 4e to the power of 4 times a half.
Yeah.
So 4e squared.
Mm-hmm.
And then 80. Oh wait, have I over differentiated that?
I don't know where the 80 is coming from.
So I just did 2 times 4, sorry, and then minus 3.
That would be double derivative you're thinking of.
So 4e squared. And then I'm guessing now I need to sub that all into the thing.
Yeah.
So into the 4x.
Into y minus y1 equals x minus x1.
So e to the 4x is y1. Or is e to the 4x just y?
E to the 4x is just the f of x. Yeah, that's just in general.
Okay. I think I'm a bit stuck.
So all you're doing is the equation of a straight line. So instead of y equals mx plus c, we're just writing it this way: y minus y1 equals mx minus x1, and that's so you don't have to find c. And you stick y coordinate there, gradient there, and x coordinate there. And so what was the y when you subbed in the x to the f of x?
When I subbed in the x, it was e squared.
Yeah, so it's y minus e squared.
So y minus e squared is equals to m. And then
so m is the gradient. That's what you get when you sub a half into the derivative.
So was that 4e squared? And then brackets half.
Other way around?
Oh, sorry, x minus a half.
Yeah. That's it. And so you've got your y, you've got your x, and you've got your m. So it's just the equation of a tangent. Any questions there?
So if I wanted to do y equals mx plus c, would that still work, or that wouldn't work?
Yeah, it'd still work.
Okay.
Yeah, so you could find m the same usual way. You would differentiate it and then sub in the x, which is a half. And then you'd sub in, well, you'd have to find y by subbing x into the f of x. And then you'd have to sub in y, m, and x to solve for c. but instead we just subbed in y, m, and x, and that's then our answer. They wrote it in terms of like there's a plus c, so the c was minus e squared, but whichever way you do it, they didn't say you had to write it that way. Okay, sorry, my pen's kind of wonky. Okay, so what do you give yourself for that stuff?
Probably like a half, I think.
Okay, I think your difficulty is in equation of a line. Okay, exponential modeling. So modeling, applying it to the real world. How about this one? Example 5.
So okay, so for a so do I just need to put in 15 into R or into T, sorry.
Yep.
So 160 and then minus 0.006 times 15. And so and that's about 1,462.
Let me just see. What is, put into calculator just the numerator, the power, minus 0.006 times 15.
Yeah. So I think I put one extra zero by accident.
Okay.
So I got 146.
So that'll be minus 146 as the power.
Sorry, I'm not.
Wait. No. Are you? Oh, so how did you get minus 100? Or how did you get 146? What did you put in?
I put 160 to the power of minus 0.006 times 15.
And what exactly does the calculator say?
146.2289896.
So that's roughly 146. Now put in minus 0.006 times 15.
It says minus 0.09.
0.09. So the difference is, so I put this one 0.09. So if we check, I get the same number, that 146 number.
Yeah.
And if they wanted it like to 3 sig fig or something, you'd say 146. But if they ask for an exact value, you would give them this one. That's the exact value, and then this one is the estimate. Okay, B.
So I don't actually have to give them like an exact answer. I just need to say I just need to make the equation just like how like times 15 basically.
Okay, so here they said 146.2, but they weren't clear about it. If we just go back a second, this one said exact. Find the exact. And so sometimes they want exact, which means it has E in it. And then sometimes they just want an estimate.
Yeah.
So our one has E in it. It's like pi or whatever. So it's exactly that. And then we just estimate it's 3 sig fig. How about B?
Okay. So Is that just like the starting density?
Correct. Yeah, because it would be like t to the power of 0. E to the 0 is 1. 160 times 1. So it's when the time is 0. So that's the starting density. C.
Okay. So now I need to use do I need to? Oh yeah. So now I need to do 160 e minus 0.006t, and that I just need to differentiate that.
Mm-hmm.
And so would that be um minus 0.96 e to the power of minus 0.006t.
Minus 9.6, was it?
Oh, sorry, 0.96.
Sorry, my pen wasn't working. 0.96 e to the minus 0.06 t. They want it in the form of something times p. Let's see, something times p. So what we just did was 160 times minus 0.06. So minus 0.06 times 160 e to the minus 0.0. Oh, there's two zeros. 006. Sorry. 006 t. So that's what you did basically, is it?
No, I didn't do that.
How did you get minus 0.96?
Oh, sorry, that is what I did. Yeah, sorry, yeah.
Okay. What is 160 e to the minus 0.006 t the same as?
1. I'm guessing because it's so gonna to 1.
No.
P.
Yeah. And so, short way of writing that?
So minus 0.006 times P.
And short way of writing that is?
Just minus 0.0
6 times p. Short way of writing it?
6p. I'm not sure.
Yep. So just without the time sign. So the way you differentiated this was power, like derivative of power times coefficient.
Yeah.
This whole thing was the same as p, and so I just, instead of that, you write p, and so it's minus 0.006 p, and what they wanted it in the form of was kp, and that's why you have that p. You just subbed it back in and made it a bit simpler.
So I don't need to do that minus 0.96 thing, basically.
No.
Yeah. Okay.
But it's correct, all of that, but they just wanted it in terms of p. Okay, how about D?
So is that part E or part C? That's part C, isn't it?
Yeah.
Would I just say that's just the initial equation or something like that, or
Interpret the significance of the sign. So this has a negative sign.
so it's negative. So do I say something like that means that the field's constantly, the density is constantly decreasing or something like that? I'm not sure.
Yeah, so density decreases over time. And how about E?
Um,
How would you do it?
uh, so sketch graph of P against T. Well, I just put 116 minus 0.006t into my calculator.
Yeah, so instead of P, it's Y. Instead of T, it's X. Just put that in your calculator. And it will look something like this. Just your standard exponential graph. What's the y-intercept?
The y-intercept is 160.
Let me think about this. Yes, I believe it's 160. Oh, and actually, t is time, so time can't be negative, and so we won't have a negative side, I think. And what else can I say? Yeah, that should be fine. Let's take a look. Oh no, sorry, because it's decreasing. So because it's decreasing, because it's decreasing, it will be other way around. So from that side, like that, and then time can't be negative, and then this was 160 as the intercept.
Yeah.
That's it. 160 as the intercept. 160 is initial value. 160 minus 0.96. Hold on. K is minus 0.96.
Oh, wait, this is K as a constant to be found.
Doesn't look. Let me just check. So P is 160. Yeah. So dP by dt is minus 0.006 times that. K is minus 0.96. I don't think they're right about that. I think they're wrong there. I think the way they phrased this, KP, K is minus 0.006. Well, we'll see what the exam questions look like.
Yeah.
No, why would they do that? That's not correct. They made a mistake. Interpret the significance of the sign. It is as K is negative, the density of pesticide is decreasing, so it's exponential decay, and that's what the graph looks like. Okay, any questions there?
No.
Okay, no. They made a mistake with part C. So P is definitely 160 e to the minus 0.006t. dP by dt, where you get this minus 0.96, is minus 0.006 times that. That is the same as P, and so it's definitely minus 0.006 P. Okay. 14C, exam question. Let us try it.
So so I should sub in 6 into 2.9.
Yep. How would you do B?
So
Or I suppose, what would be an exact value? No, they wouldn't want an exact value. It's money, is it?
yeah.
So yeah, you would just sub it in. That'll be all right. How would you do B?
Find the value of dv dt one. T is equals to 2. So for 1, I had to do 29,000 e to the power of minus 0.24, I think.
dv by dt.
And then will the answer be, so minus 0.24 times.
Did you?
Sorry, is it minus 6,690 e to the power of minus 0.24?
To the power of what, sorry?
0.24.
That's when you sub in 2. And where did the minus 690 come from?
Oh, sorry, I meant minus 6,960.
And where did that come from?
I did minus 0.24 times 29,000.
What is the derivative of this, just in general?
Is that just e to the x, or?
No. If you just had to get the dv by dt.
I would just do minus 0.12 times 29,000
Yeah.
e minus 0.122.
Yeah. And so it's not minus 0. So you said minus 0.24 times that, but it's actually, there's no t here, so it's just minus 0.12 times that. So I think it will be half of whatever it was before. And if we were to write that as thing in general, dv by dt would be that p. Yeah. And so then you just sub in 2, then you just sub in 6. That's all right. And any idea about C?
So that's the answer, that minus 0.12 times 29,000 e minus 0.122.
So what you would then do what you did. So you would do e to the minus 0.24.
So that's the final answer.
Well, this is money, and so I think I would just do it to 2 decimal places.
Okay. Right. So I now need to put that into two, and I need to do that and put it into 2 decimal places.
Yeah.
Okay. I got a minus number.
Okay, what is it?
Minus 2,737.46.
6. Okay. How about question C?
So I'm guessing it's just the same thing. So minus 0.12 times 29,000 to the power of 6 times minus 1.2. Minus 0.12.
Yeah, and don't forget the e. So times e to the minus 0.12 times 6. I meant this part C here.
Oh, sorry.
Yeah, because I think you're fine for the part 2 of B.
Okay. And then so do I need to say something like after 6 years it just goes into negative numbers?
So I think your one became negative after 2 years or something, was it?
Yeah.
So I think there's a problem with that in the context of this question. Any idea what that might be?
That the car depreciates a lot under like a small space of time. I don't know.
If can you sell a car for minus £500?
No.
So I think the problem is that, yeah, like that would be like you paying someone to take your car away or something.
Yeah.
I don't think that's gonna happen. Just want to see. So I've sub in 2, and that's what you get, minus 2,700. Sub in 6, minus 1,700. The value decreases over the first 6 years of ownership. The decrease happens more quickly at first and then more slowly. No. My mistake, sorry. I was thinking of something else. This is for dv dt. So that is the rate of decrease. So in the first 2 years, it goes down in price by 2,737. After 6 years, the rate of decrease is going down by 169,390 per year, and so the rate of decrease is decreasing over time, so it's kind of leveling out. Any questions there?
So sorry. So back to B1.
So B1,
Yeah.
I was thinking that I thought we were subbing it into this up here.
Yeah.
It was actually, we were subbing it into dv by dt, so that tells us the rate of decrease.
Yeah.
And so year 2, you're losing approximately 3,000 per year, and then by year 6 it's losing approximately 1,700 per year.
Yeah.
Of its value. Yeah, because dv by dt gives you the rate of change of value over time. Any questions? Any other questions?
No, I don't think so.
Okay, so tricky stuff. Okay, let's see. We've got 2 things here. I want to try the first one that was there a second ago. Let me take a look at this. Yeah, it looks alright. Okay, this is the one. Let's try this one.
Okay.
So how would you do part A?
So do I need to just so you wanted to, do I need to just put 4 point? Oh no, it says estimate, so that means I should sub in 4.394, shouldn't I?
Mm-hmm.
And so that would be e to the minus 0.13 times 4.934.
Yeah.
And so I got 0.53.
530, is it?
It's 0.526.
Okay, we'll go with that. 526.
It's actually 0.52. It's 527.
All right. B.
So Here. So I think I need to do. So I just need to do minus 0.3.
1, 3.
Yeah, sorry, minus 0.13.
Mm-hmm.
Times e to the minus 0.13h.
Mm-hmm.
And so that's just minus 0.13e minus 0.13h.
Yeah. And they want it in terms of P.
So Kp. So does that mean that k is equals to minus 0.13?
Yes. And that's because P is e to the minus 0.13h. So instead of e to the minus 0.13h, you can write P. And so it's minus 0.13p. And so that is what K is. So this was the contention a second ago. I want to check that. And so K is minus 0.13. K is minus 0.13. So that's very similar to the one we did earlier. And they were saying it was a different answer. But yeah, I knew we were right. Okay, how about C?
Okay. Um, so k is negative,
Yeah.
and so um, does that mean that atmospheric pressure? Do I need to then say some sort of description after that, or
Yep. Like, what is the significance of that, of the negative sign?
so is that like the gradient or something?
Yeah.
Does that just mean that the atmospheric pressure is decreasing?
That would be if the E up here. No, I think that would be fine. Therefore, the and for in part B, what I would say, it's the rate of decrease. The rate of change is decreasing.
Okay.
Rate of, what's my pen doing? Come on. Rate of change is decreasing. I think they might just be a bit more specific. The rate of atmospheric pressure or something like that. For question C, the atmospheric pressure decreases exponentially as the altitude increases. Okay, so no, they just kept it simple. So they didn't talk about rate, just the atmospheric pressure decreases exponentially. That's the important bit, as in altitude increases. So it's a bit like correlation. As atmospheric pressure decreases, altitude increases exponentially.
Okay.
Yeah.
So I need to put the exponentially in.
I think that's the important bit, yeah. No, I think that just makes it accurate, but it's basically, it's like negative correlation.
Yeah.
So as height increases, atmospheric pressure decreases exponentially. And D.
And then um, so do I need to use the answers before to work this out?
I think that might help.
Um, so do I just find the difference between 2 kilometers, between two different like kilometers, and then work out the percentage of that? Or
I think that'll work. Let me just take a look. And so we looked at, see, this was part D. So they subbed in 0, they subbed in 1, and then they, did they change over the original to get percentage change?
yeah,
Yeah, times 100 to turn it into percent. So it was roughly 12%. So it's like, going down by 12% each year. Any questions about that one?
no.
Okay, so this is exponentials, which is difficult, and modeling, which is using like real world stuff, which is also difficult. What do you give yourself there?
I think I'll give it like 0.75 or something like that.
Okay, so we could always practice them a bit more. Next is logs. Maybe we could do one question at the start next time and then next stuff. So logs is next. Do you want to do that next or something else? Logarithms are the opposite of exponential.
Yeah, just continue, I think.
Okay. And you're hearing lots of stuff in the news probably about coronavirus being exponential. So that's what this stuff is all about.
Yeah.
Like it kind of, quickly goes like that. Any questions for me in general?
Are you able to